Welcome back. Now we're ready to start taking the magnitude of some vectors. We can actually do this quite easily in the engine, as the engine has lots of built-in capabilities for doing vector calculations that make our lives easy as developers. Now, this basic map is kind of filled up with some of our work that we've already done, so I'd like to create a new map for a new set of experiments. So I'm going to go to File, choose New Level, and I'm just going to create a basic map. Click on Create, and look at our floor. It's way down there, at least on my screen. I'm going to select it and press F to focus in on that floor. In fact, I can focus in on that player start by selecting it and hitting F, and there it is. And this map is going to be used to test out some of the algorithms that we're going to create. Algorithms are just a set of instructions. It's basically code that performs some kind of action, and we're going to create some of our own. So I'm going to save this level. I'm going to go to File, Save Current Level As. We're going to go to our Maps folder, and I'm going to call this Algorithm Testing. So we can test out our algorithms in this new map. Now, I'd like to create a situation where I'd like to find the magnitude of a vector. And a good scenario for that is when I have two actors in my world, and I want the vector from one actor to another actor. And we have some debug actors. We have the BP debug actor class, and we can drag a couple of these into our world. I'm going to drag one right there in front of the player start, and I'm going to drag in another debug actor right there. So I have debug actor and debug actor 2. I'm going to rename these just so it's easy for us to know which is which. I'm going to call the first one DA, short for debug actor. It's going to be called DA loc 1, loc for location. I'm going to select the other one. I'm going to call this one DA loc 2. So we have two actors representing two locations in space. We can press play and see those debug spheres right there on the floor. We have actors 1 and 2. Now, I'd like the vector from DA loc 1 to DA loc 2. I'd like the vector that starts at 1 and ends at another. And I'm going to do some calculations in the level blueprint. So I'm going to open the level blueprint. Here it is. We got begin play. We have tick. And I'm going to take DA loc 1, select it, come back into my level blueprint, right click, and get a reference to that. And I'm going to get a reference to the other debug actor, DA loc 2. I'm going to right click in here and get the reference to that one as well. And I'd like the vector from DA loc 1 to DA loc 2. So how do we get the vector from one location to another? So these are two actors, and we know how to get their locations. That's quite easy. We can simply use get actor location. I'm going to get the actor location for DA loc 1, and I can simply duplicate get actor location and plug in DA loc 2, and I now have two vectors. One is a position vector. It's the vector whose XYZ components are the XYZ coordinates of the location of DA loc 1. If we go to DA loc 1 in our level and select it, we look at our location here. These XYZ coordinates are the XYZ components of this vector, right? And we know that DA loc 2 is the location for that debug actor. Now, how do we get the vector from one location to another location? How do we get that direction vector? The answer is quite simple, but let's take a look at this from a theoretical standpoint. Now let's take a look at a hypothetical example in two-dimensional space. When thinking from a theoretical standpoint, it's generally easier to think in 2D, and these concepts extend into higher dimensions, such as 3D. Now our goal here is to find the vector from point A to point B. Now we can represent points A and B as dots here in the world. We'll call this blue dot point A and this red dot point B. And I want a vector from point A to point B. Now we know that point A can be represented by a vector. A location in 2D space has two coordinates, right? X and Y. And we can store those in a vector. In fact, we saw that get actor location returns a vector. And the x, y, and z components of that are the coordinates. And we can always think about this vector as the vector starting at the origin and ending at that location. So here in 2D space, VA, the vector from the origin to point A, has the components XA and YA. And point B, the red point, has its own location, and that can be represented by a vector as well, vector B, which will have x and y coordinates, xb and yb. Now, the goal here is to find the vector from point A to point B. We want this vector. We'll represent it by a green vector. We'll call this VC. So the question is, if we have 2 points in space, 2 vectors representing 2 locations, how do we get the vector from one location to the other? Now, we've seen how to do this using vector subtraction, but let's think about this a little more deeply. In order to get the x and y components of the VC direction vector, we'll call them xc and yc. Geometrically, those values are these distances here, formed by this right triangle. xc is the distance in the x direction from the tail of VC to the head of VC, and yc, the y component of this vector, is the distance in the y direction from the tail of VC to the head of VC, and these distances are represented by these red dotted lines here. So if we want to calculate these, we can easily do so, provided that we have the information we need, which is the components, x and y, of both VA and VB. So if we just look at the x components of these vectors, then for the location of the red dot, that location is going to have an x-coordinate of xb. That's the distance from the origin to this x location traveled along the x-axis. And the x-coordinate of the blue point is xa, stored in our vector. And what we want is the distance along the x direction from the blue point to the red point. That's going to be our x component for vector c. So we can simply take xb and subtract xa from that. We have the total distance from the origin to xb and the total distance from the origin to xa. We subtract a away from that and we get that distance in between. That's xc. Now we also want the y component, and we can take the distance traveled from the origin along the y-axis up to the red dot's y coordinate, and we can take the distance from the origin up to the blue dot's y-coordinate, and we can take the difference between those. We can subtract in order to calculate yc. That's going to be yb minus ya. Now, something kind of funny is happening here. yb, if you look at the distance from the origin traveling up that green y-axis, we'll reach yb before we reach ya. This means that yb is a smaller distance than the distance from the origin to ya, clearly. So if we take a smaller value and subtract a larger value, we're going to get a negative number, right? But look at our VC vector. It's pointing down and to the right. So if we're traveling along the y-axis from vector c's tail, going down towards the head, we're going down in the negative direction. So VC is going to have a negative y component. So this is actually correct. So this tells us that if we ever want a vector from point A to B, we're always going to use subtraction, right? VC is the difference in the values between A and B. This is component-wise subtraction, right? That's vector subtraction. And a good way to think about it is the vector from A to B is always the destination minus the starting point. So if you're going from A to B, B is the destination. So it's always going to be B first minus A. So this component-wise subtraction is really just vector subtraction. It's vector B minus vector A. So if you have 2 vectors representing 2 locations in space, you can take the destination minus the starting point and always get the vector from point A to point B. So let's do this calculation in our project. You see, we have 2 points in space, location 1 and location 2. And if we want the vector from 1 to 2, we have to subtract the location of 2 minus the location of 1. So I'm going to take dA loc 1 and move it down because we're going to do vector subtraction. Now, vector subtraction is just as easy as vector addition. We can drag off of a vector value and type the minus key, and we have subtract. And if we select it, we have a subtraction node, vector subtraction, which expects two inputs, both of vector type. And it's going to take the first one and subtract the second one. So we're going to plug in that second one, and we now have a vector value that is the vector from DA-loc1's location to DA-loc2's location. And I'd like to store this vector in a variable here on the level blueprint. Now, we've seen previously that we can do that by going over to the variables section and clicking plus to add a new variable, changing its type to vector and renaming it. Well, there's actually a handy shortcut that you're going to use all the time. And that shortcut is to take the return value of the subtraction node, the one that we would like to store in a variable. We can drag off of it and release it, and look at the top option here. It says promote to variable. So we're taking this value and promoting it, which is the same thing as creating a new variable of this type. Now, let's select promote to variable, and look at this. We have a new set node for a newly created variable automatically named new var, var for variable. Now, new var is a very bad name, and Unreal Engine doesn't expect you to keep that name. That's why it's highlighted and eagerly awaiting for us to rename it. So we're going to rename it. Now, this is going to be a vector from, so I'm going to call it from 1 to 2. Now, I didn't put any spaces in the name, but notice on the set node, Unreal Engine just adds a space there for us after each word, separating the word from the letter, but it doesn't give a space after numbers. So if you want that space, we can always make use of underscores. We can put underscores between the words and the letters. That'll give us spaces here on the set node. That may not bother you, but if it does, that's how you can get those spaces. So by promoting to a variable, we've just saved us a few mouse clicks. We didn't have to go add a new variable, change its type, click on it to rename it. Promoting to variable is a shortcut for all that. And now we have a vector from point 1 to point 2. Now, the set node is not connected to anything, so this will never actually be executed. We have to specify when to execute it. We can do so by connecting it to the begin play node. And now on begin play, at the beginning of the game, we're going to take vectors 1 and 2, perform the vector subtraction of the location of 2 minus the location of 1. This gives us the vector from 1 to 2. So now that we have this vector, we can take a look at its magnitude. Now, in Unreal Engine, the magnitude is referred to as the length of the vector. Magnitude and vector length are the same thing. They're synonymous with each other. And to get the magnitude of a vector, we simply take that vector value, we drag off and release, and we can search for vector length. Now notice there are several options here. The plain old vector length is just vector length. And notice this node requires an input of type vector and has an output of type float. Float is a scalar value, a single value, rather than a vector of values, because the vector length is a scalar. It's a single value that tells us how long that vector is. And we can see how long that vector is by using a print string node. Let's use print string, and we can simply hook up this float value into the in string and get a float to string conversion node, and we can simply hook this up. And if we want to print this string for a long duration, such as 600 seconds, we can set its duration there, and we can go ahead and press play, and we can see that 510 and some change is the length of the vector from location 1 to location 2. And we can always experiment by taking these vectors and moving them around. I can take DA-loc2 and move it farther away. And if I press play, we can see that that vector length is larger. It's a longer distance from DA-loc1 to DA-loc2. So it's relatively easy to find the length of a vector. And it's just about as easy to find the vector from one point to another point in space. And in fact, it's even easier to find the distance between two vectors. We don't even have to go through all the trouble of performing vector subtraction and promoting to a variable. If all we want is the distance from one point to another point, there's an even easier way to do that. All we have to do is right-click in the event graph and type distance. Now, there are lots of things that have distance in the name, but we want distance with vector in parentheses. You can even type vector to filter the search even more. Now, this is a function under math in the vector category. If we choose distance vector, we have this node, which takes in 2 vectors and returns a floating point value. Distance expects 2 locations in space, and it'll tell you the distance between those 2. So if I take these nodes here, DA loc 2 and loc 1, get their actor locations, we can duplicate those nodes and hook them in here. Well, now we have that distance already. We didn't have to get the vector from 1 to 2. We didn't have to get the vector length. All we need is to use the distance node. And we can print that string as well. I can hold Alt and break these wires here and bring that print string up here. Hook up the result from distance to the conversion node and simply hook up this print string to begin play. I'm going to hold Control and detach this wire and hook it up here. And now I don't need any of these. I can delete all of them. And we now have a few less nodes to do the same exact thing. Now, why did we go through and do this the hard way if there was just a single node that can give us the distance? Well, sometimes you do want a vector from one location to another. So it's important to know how to calculate that. In other circumstances, you may not have 2 locations in space. You may just have a single vector and you want to know what its length is. So it's important to know both how to calculate the length of a single vector, and it's also important to know about the handy math utilities that the engine has to make life easier when you need to perform calculations. So with this new set of nodes, we can press play and we can see that we still have that same value. That's the distance from one vector to the other. The distance is just the length of the vector from one point to another point. Excellent job, and I'll see you in the next video.